with Phil Zito, episode 461. Hey folks, Phil Zito here, and welcome to episode 461 of the Smart Buildings Academy podcast. We're back. It's been a long summer break. We got a lot of things to update you on. I'll do that at the end of the podcast. Today's episode is sponsored by Smart Buildings Academy, specifically by our free skill assessment. We have created a comprehensive and completely free technical skill assessment that's designed to help you and your team evaluate your current knowledge and identify any areas of improvement. We all know that a lot of training is done in the fall and winter, as well as a lot of budgeting for training is done in the fall and winter. So whether you are a seasoned professional or a newcomer, I really encourage you to go to smartbuildingsacademy.com/skills. Once again, that is smartbuildingsacademy.com/skills to take your free skill assessment today. Okay, so summer's over. At the time I'm recording this, it's August, and a lot of you are wrapping up your K through 12 projects, your quick hit commercial real estate summer projects, maybe some higher ed or healthcare projects. And maybe you're not happy exactly how they went. Maybe you're getting callbacks. Maybe the project was estimated for, $10,000 of margin, and when everything is reconciled, you only executed at $8,000 of margin. And you're wondering why? What am I doing that's causing slippage? What are some of the areas that if I get ahead of them in, the upcoming fall and winter season, and specifically as well, the summer season next year, can I go and reduce these callbacks? How can I really impact the efficiency and the productivity of my technicians? I've got a list of 20 common mistakes that building automation technicians make. I myself have made these along my career, and I'll talk through them in detail. I think we'll get through 5 today, so this may be a multi-part series. But with that being said, let's start with number 1, which is incorrect wiring and connections. We've all seen this. For example, a common one I see is 4 to 20 milliamp when people wire it up like it's sourced from external voltage versus internal voltage. Another common one I see is people incorrectly doing low side or high side switching on outputs. At the end of the day, the reason I find incorrect wiring and connections so common in building automation work is because quite often a lot of firms use outsourced electricians in order to go and do their wiring, their termination. And in some cases, if you're in places like Chicago, New York, other cities, you may have to use union electricians for your installation. Others of you may have your own in-house installers and electricians who go and execute the work. At the end of the day, it's really not so much about who is doing the work. It's about how do you go and get them prepared to do the work. So the easiest way, and I should rather say this is the simplest way. It's not necessarily easy because this is going to require that you have the resources to go and do this. But the simplest way to address incorrect wiring and connections is first, take your control submittals, go with the electrician to the site, do one of each type of termination with them. There only should be a dozen or less termination types with that electrician. You're terminating to some actuators, you're terminating to some VFD drives, some different IO, maybe you're running some safety circuits, maybe you've got a motor control panel, but at the end of the day, you're not terminating to too many things. So go with that electrician, line them out, correct them where they make mistakes, and then make sure that they understand what they're doing. About halfway through, this is going to be percent of completion, probably 60%, where your electrician should have the majority of the things wired. At this point, you'll want to go and do another spot check. You want to spot check the devices that have the most quantity, in my opinion. Here's why. Now, I know some of you are going to say, well, Phil, wouldn't we spot check the most complex systems, meaning the chillers, the air handlers, the boilers, etc. And, that would be my initial thought too. But here's the thing. Someone is doing a single chiller, someone's doing a single air handler. They're more likely to be focused on that. And if you lined them out and showed them how to do it, the likelihood of them doing that right is high. But when you start to do 400, 800, 2,000 VAV boxes, that's where mistakes start to happen. That's where people get sloppy. Maybe they're doing a floating actuator and they miswire things. They get the clockwise and counterclockwise crossed. And next thing you know, you've got 100 boxes that are improperly wired. Maybe the communication bus polarity is crossed. There's a variety of things that could be wrong. So this is why I recommend spot checking the units, typically terminal units, fan coil units, rooftops, first. And then if you find errors there, I'm willing to bet you'll potentially find errors in the bigger systems as well. Okay, so how do we fix this? One, I've seen people put on an electrician kind of boot camp. They bring all their subs in for 4 hours. They feed them, they train them on how to do the wiring the way they want the wiring done. A lot of hands-on practice, and then they're sent out in the field. That's getting increasingly hard to do with the shortage of subcontractors. That's why the second way of doing it, the way I recommend, is actually going out onto the job site and then going and training these people when the materials arrive. Quick bonus tip. If you have the capability with your estimating and material ordering software, order systems. So what I mean is if you have an air handler, order all the parts in a batch, get them all in the same or very, what do I say? How do I say this? Get them on the same pallet, get these parts in the same box on the same pallet, and hand them off to the electrician and make sure that they don't just throw it all in the job box and it all gets mixed up. Make sure that they keep these things in their respective systems. That way you're not using the wrong sensors, you're not mounting the wrong sensors. It's a way to avoid using the wrong material. All right, let's go on to action item number 2. Action item number 2, I've got a list here. Which one would be the most impactful? I'm at a toss-up between incorrect sensor placement and poor documentation and labeling. I know some of you would probably be like, go to commissioning, go to point. That's important, but as far as things that I've seen cause issues at job sites, sensor placement is a big one. It's where, you don't work, and it's one that's actually really easy to fix and get ahead of. Whereas point to point is more of like, have I trained my team? Have I ensured that my PMs are holding them accountable? And then poor documentation and labeling. That's a whole can of worms that we'll get into later in this episode. But incorrect sensor placement, that's a quick one to hit. First, make sure you're ADA compliant. Make sure your sensors are not going to have to all get fixed and re-put in the drywall. And I cringe because I remember an electrician who didn't follow ADA compliance and it was ugly. There was a deductive change order for having to go and fix drywall and all sorts of stuff. So, right, the ADA compliance, working with the mechanical contractor to ensure that the sensors are placed in the right area, and then also understanding what are you trying to achieve. So if I'm in school and I'm trying to achieve temperature of a cafeteria, putting the sensor in the return duct may be more beneficial than putting the sensor on the floor where it's going to get damaged. It's going to have all sorts of issues. But if I'm trying to get room pressurization readings for a hospital, then where I put that, I may have to have a very specific placement of that because of issues with doors opening and pressurization changing, things of that nature. I'm not going to go too deep into that. But proper sensor placement is going to be a big one. So to this point, we've got incorrect wiring and connections, and we've got incorrect sensor placement. The third area that I'm going to focus in on is going to be poor documentation and labeling. So we've all been to customer sites where we're trying to sell them on a retrofit or maybe some service work, and we ask for the building's control drawings. They don't have them. They haven't been updated in 20 years. They don't reflect the accurate installed conditions. I recently had this on a consulting engagement we did where we were writing a PM RFP for a client, and they had added controls to a couple buildings, but we weren't made aware of that, and it wasn't in the documentation. So we had to go and adjust that RFP that we were helping them write. And that is a direct effect of poor documentation and labeling of components. We've all been there. We've walked into a mechanical room. It's a spaghetti's nest of wire. We can't really figure out. Actually, funny enough, that's how I got shocked the first time by 120 volts was unlabeled 18 gauge wire connected by an alligator clip that I thought was low voltage, but was 120, and threw my elbow back into a piece of sheet metal. That sucked. So properly labeling wires, properly documenting your work. So as your technicians close out the job, here's the process I recommend. The electricians have a set of drawings and a set of MEP and spec, and they redline as appropriate. You, the technician, have a set of drawings, MEP, spec set, you redline as appropriate. These two documents are coalesced or combined at the end of the project, and anything that conflicts, a discussion between the electrician and the technician happens, and that is resolved. Once that's resolved, then that resolution is placed into the O&M manuals, the operations and maintenance manuals, and the as-built job drawings. That's what I recommend doing, and that will help you in a couple ways. One, you'll actually know what's in the building, so that if you get into a dispute where a customer's calling and saying, there's this issue with this system, it's not doing XYZ, and you pull up the job drawings, you're like, and I've seen this actually happen. Well, you don't have that system, or that system doesn't have cooling, or that system doesn't have heating, or there was a decision by the commissioning agent to run the space at 78 degrees. That's why it's running at 78 and not at 74. And having that documented is going to be key for you going and being able to keep your projects accurate, having a single source of truth, and really being able to, this probably isn't the right way to say this, but it's the only way I can think of right now, which is to defend yourself during the warranty period. Okay, next up, overlooking system integration requirements. I know some of you are probably screaming at this point, you haven't got the point-to-point checkout yet. I know I haven't, but I will by the end of this podcast. I promise that'll be number 5. But so this point, we've done incorrect wiring and connections. We've talked about incorrect sensor placement, and we've talked about poor documentation and labeling. Now we're going to talk about overlooking system integration requirements. I see this quite often. You'll get a spec, you'll get a MEP set, and that spec will say integrate lighting system. The MEP spec, my gosh, can't speak. The MEP set of drawings will say stuff contrary to that. Instead of submitting an RFI or an RFC, the field technician will just simply go with the MEP set or whatever is on the control drawings. It reminds me of that movie Anchorman, where they're like, Ron Burgundy will literally read anything on the teleprompter, and I mean anything. Well, it's kind of like that. Some technicians, They will do whatever is on the job drawings, and it doesn't matter how illogical or how much that contradicts the MEP set or the spec set. And let's be real, your majority of installing technicians or construction techs, they're not going to read the spec or MEP set. They're simply going to read the control drawings and do what's on the control drawings. So if the control designer does not resolve any conflicts between, if the MEP says use BACnet IP to integrate with lighting, and the spec set says use hardwired contacts to integrate with lighting, and you don't resolve that and put the appropriate documentation in the control drawings, then the technician is not going to go and properly implement that. Now you may be saying, okay, Phil, that's lighting. That doesn't happen on all our projects. But how often do you see a chiller? And that chiller has a BACnet IP card, or at least it's supposed to in the spec, but it doesn't in the MEP set. So the controls designer doesn't put it in there, and the mechanical doesn't see it either. So no one orders the BACnet IP card. So now all the BACnet points that are supposed to be monitored that are checked during commissioning don't exist. So now the commissioning agent is saying, well, this system isn't functional as designed, as specified. And you're like, crap, I've got to get a BACnet IP card as fast as possible. Oh, all the BACnet IP cards are out of stock because it's the middle of the summer and every other job site is using them. And next thing you know, you're in damages or project delays simply because someone didn't RFC or RFI, request for clarification, request for information, a spec set. Once again, you're hearing this stuff. It may seem super basic, and it really is, but just simply having a sit down with your project managers, having a sit down with your technicians, having a sit down with your electricians to go over some of these things prior to executing the project, this will save you a lot of time. All right, and I told you we would do it. Failure to test and verify systems. Failure to perform point-to-point checks. Okay, so there's a couple ways we can do this. There is the simple software check. Are any points offline? Are any points, this is a room temperature sensor, but it's showing 140 degrees. Either it's wired to the wrong thing, either I have a conversion table in my controller wrong. But at the end of the day, checking your points, making sure that 1, they map into the system. 2, they are showing the appropriate values. And then 3, that they are to the right device. So there's a couple ways you can do this. 1, checking that they map into the system, pretty simple. You discover them as part of the process. You have a list of points that a system should have. You check them off as they're discovered, making sure they're showing the correct value. That is, if I've got a room temperature sensor, it should be showing 72 degrees. I can simply see that it's showing, 72, 74, whatever degrees and say, that's reasonable. Or I could take it a step further. I can go with a calibrated temperature sensor and perform temperature calibration and offsets to ensure that I've got the correct calibrated sensor. You can do that as well. Now, I've heard of some folks doing bulk calibration in their company offices. They'll take all the sensors, plug them into a controller that's configured, and do bulk calibration. I do not recommend that because here's what can happen. If you have any form of resistance that's introduced to the wire, that can cause your calibration to be off. So just be aware of that. Now, the other way of doing this, it's a little bit more intense, is that as the electrician hooks it up, you've got a technician on site. The technician's working on other things, but the electrician says, I just hooked up VAV box 1. The technician checks that VAV box 1 maps in, all the points work, and there you go. I've also seen some, very few, but some electrical outfits that are given the software for the building automation system, and then they not only terminate the points, but they actually map them in and configure them. I'm seeing this become more common, but it is still a very slim amount of electricians that are doing this right now. Okay, so we covered 5 specific topics and we're at about 20 minutes. So I think this is where we'll end it. We discussed incorrect wiring and connections. We talked about how to resolve that by lining out your electrical subs. We talked about incorrect sensor placement. Once again, lining out your electrical subs, making sure that you're coordinating with the MEP. We talked about your poor documentation and labeling. Talked about a couple ways to address that. We talked about overlooking system integration requirements and really how that's largely on the controls designer to catch and then the technician to validate. And then finally, we talked about failing to test and verify systems, primarily point-to-point checkout. All right, folks, I hope you found this podcast valuable. Everything will be available at podcast.smartbuildingsacademy.com/461. Once again, that is podcast.smartbuildingsacademy.com/461. Thank you so much for listening, and I look forward to seeing you in the next episode. Don't forget to check out our free skill assessment. If you're looking to know where your team is at or where you're at, then go to Building Automation Monthly. See, I was about to say the old name of our company. Go to smartbuildingsacademy.com/skills. Once again, that is smartbuildingsacademy.com/skills. Thanks so much and have a